Hi guys. I'm recording this a second time because I screwed up the first recording. So bear with me. My marking is already in here. So if we look at this, given that ABC is similar to AB prime C prime, we could determine the length, or could we determine the length of AB prime? Now remember, this is the symbol for similar. It's this little mark. Sorry, I did that wrong. That mark is the similar mark. So you see that here. What does it mean to say that ABC is similar to AB prime C prime? Okay, now normally this is where you guys would have a chance to talk and we discuss it, but since we're at a distance right now, if you guys want to pause the video right now, don't look at the answer and pause the video and look it over, think about it, come up with an idea, and maybe share it with someone in your class, see what everyone thinks. You could even text about it in the group text and see what people think. Go ahead and do that. I'm going to pause for just a second. And I'm assuming you paused the video. If you didn't, that's okay. We're going to go ahead and go on. So, what it means is that the measures of corresponding angles are equal. Corresponding angles means the angles that create the shape. The angles are equal to each other. They correspond. The ratio of corresponding sides are equal, so that is AC prime. This is AC prime. AC prime over AC, which is AC. AB prime, that's AB prime over AB equals B prime C prime, that's here, and BC, that's here. So BC, B prime, C prime. Okay? And the lines containing BC and BC prime, these two lines, this one and this one, are parallel. You can see that. How can we use what we know about similar triangles to determine the length of AB? So A to B, how long is that? The lengths of the corresponding sides are supposed to be equal in ratio. AC prime over AC, AB prime over AB. They equal each other. It's the same as saying 15. We know this is 15 here. A to C prime is 15 over 5. A to C is 5. We can see that right here. We can see our 15 here. They're the same. They're laid over the top of each other, so we can put them over each other. Equals AB prime, because we don't know what AB prime is. That's our x. That's our x. Over 2. AB is 2. Okay. Since we know that for equivalent fractions we must multiply the numerator of each fraction by the denominator of the other fraction, so the numerator of each fraction by the denominator. The numerator of each fraction by the denominator. It's cross-multiplying, you guys. Cross-multiplying. The products are equal, so we can use that fact to find the length of AB. Let x represent AB prime. Sorry, x represents AB prime. So 15 over 5 equals AB prime over 2 is the same as 15 over 5 equals x over 2. Eventually we get 30 equals x. So AB equals x. Sorry, AB prime equals 6. So basically it becomes 15 over 5 equals, we have our x over 2. If you cross multiply, you can do 15 times 2 is 30. To get 30, you have to do 5 times 6. So 6 must be x. Okay, we're going to go ahead and move on. Go ahead and go to the next video,